In this video, we're going to talk about area bounded by a curve and the x-axis. So in my first example, I'm going to find the area of the region that's bounded by y equals x squared and the x-axis between x is 1/2 and x is 4. So first we're going to start by drawing a graph of what we're looking at. Y equals x squared is inverse square variation. It has this general, the graph has this general shape. But I'm just going to focus on this region, okay? So the region that I am concerned with goes from x is 1/2 to x is 4, and let's get some y values here. When x is 1/2, 1/2 squared is 1/4, 1 over 1/4 is 4. So this is going to be the point 1/2, 4, which might be about here on this graph. And then of course when x is 4, I get 1 over 16. So maybe over here, right? We're just looking at this small part of this graph. So 4, 1 over 16. Okay, and I'm going to draw the curve in and draw in my x boundaries, and this is the region that I want to find the area of. And to find area, what we do is we integrate the function over that x interval. So the area of this region is going to equal the integral from x is 1/2, that's my lower limit, to x is 4 of 1 over x squared dx. Okay, so 1 over x squared is x to the negative 2 dx. And x to the negative 2 integrates to negative x to the negative 1, which is the same thing as negative 1 over x. So you always plug in your upper limit first, and then you subtract what you get when you plug in your lower limit. So I'm going to get negative 1/4 minus, when I plug in the lower limit, I get negative 1 over 1/2. And 1 over a fraction equals the reciprocal of that fraction. So that's going to be 2. And so I get that my final answer, the area of this bounded region, is 1 3/4 or 7/4. Okay, so one application of a definite integral is that it allows you to find the area bounded by a curve and the x-axis. Now, there is one caveat to that, and I'm going to do a second example to explain that. So my second example is to find the area bounded by the x-axis and the curve y equals negative x squared minus 2 for x is negative 1 to 3. So if we look at our curve, this is a parabola, okay, and I'll kind of rewrite it and discuss the transformations. Negative x squared means that this is an upside down parabola. And the y plus 2 instead of y means that my parabola is shifted down 2 units. So the parabola looks something like this, okay, and where the vertex would be at 0, negative 2. And again, we're just going to look at a particular region. When x is negative 1, the parabola is at negative 3. Okay, so I'm going to draw slightly more accurate drawing here. So again, this is at 0, negative 2. And then -1, -3 is going to be here. And when I plug 3 in, y equals -9 minus 2, or -11. So we're looking something like that. Let's say that is 3, -11. Okay, the area bounded by this curve and the x-axis is between x is -1 and x is 3 is going to be this region right here. So let's see what happens when we integrate the same way we did in the previous problem. The integral from -1 to 3 of -x² minus 2 dx equals, this is going to be -1/3 x cubed minus 2x from -1 to 3. And I'm going to get, let's see, -1/3 times 27 minus 6, that's what I get when I plug in the upper limit, the 3, minus, okay, let's see what I get when I plug in the lower limit. -1 cubed is -1, times -1/3 is going to give me +1/3, and when I plug a -1 in here, I'm going to get +2. So when I add this all up, I'm going to get -9 minus 6, so that's -15. This is 7/3, so minus 7/3. And this is, I'm going to give this a common denominator. The common denominator is 3, so this would be -45/3 minus 7/3, or -52/3. So, what is wrong? What's going on here? What's the problem with this answer? Well, you should recognize that something is wrong because our goal was to find an area, and we know that area cannot be negative. So, what's going on? What's going on is the integral only finds the area bounded by the curve and the x-axis if the curve is above the x-axis. If the curve is below the x-axis, then the integral finds the negative of the area. So, there are two ways I can address this. To find the area, you can take the negative of the integral. As simple as that. Take the negative of my answer, and that will give me the area. Another option is you can also switch the limits of integration, and that will also give you the negative of the original integral that we did. So I could also do the integral from 3 to -1. Both of these will give me the correct answer, which is 52/3 units squared. So let's quickly review. In the first problem that we did, the curve was above the x-axis. So integrating over the x interval given gives the area bounded by that curve in the x-axis. In the second example, the curve is below the x-axis. Integrating over the x interval gives the negative of the area bounded by the curve in the x-axis. So the two things you can do are set up your integral with a negative sign in front of it to get the area, or switch the limits of integration so that instead of integrating from left to right, you integrate from right to left, which is the same thing as getting the negative of the original integral to find the area.